If you think the push operation of a stack takes just O of one time complexity, you cannot be more wrong than that. It is a typical stack implementation. I have wrote this code in C so you can understand what is happening inside the system in real time. The stack is having items that is going to store all the elements, and the size that represents the size of the array, and the top that represents what is the top of the stack. And whoever wants to have a new stack, they are going to call the stack new function. It sets the size as 1024 and allocates 1024 integer size elements into the items array. Then it sets the top to 0 and returns the stack. When push happens, it checks whether the top is less than size. If it is less than size, simply insert the element into the top of the stack. But when your stack runs out of space, there are not enough space in the stack to insert a new element, you have to reallocate the item. So we use the reallocate function, which actually creates a new array and copies all the data from the previous space. And we usually double the size of the previous array. So initially it was 1024, now it is going to be 2048. So after that you update the size, then you can insert the item into the stack. 99% of the time the push operation is going to fall into the if condition, and this is going to take just O of n time. But the remaining 1%, it will come into the else case where the reallocation operation happens, and the realloc and data copy will definitely take at least O of n or more than that. So what you have to tell in an interview is this 1% reallocation time, the O of n time, is amortized into all the push operations. So it is called amortization.